So, problem 1b actually has two questions to it. It actually asked you to write two methods. One method was the replace all method, the other was the undo replace all. So I'm going to split that up into two videos. This is obviously the first part of B, which is the replace all method. So the purpose of this method is to use the replace one method that was written in part A. Now remember how the AP exam works. Even if you don't know how to work a certain part of the test, if you know what its purpose was and potentially how to use it in later parts of that problem, like for instance part B, you can still use that method and continue just to pick up here, assuming that you acting like you got the first part completely correct and it does exactly what it's supposed to. So make sure that if you look at a problem and you feel like you know what's going on in one part, but maybe you didn't know what was going on in a previous part, even if it builds upon the earlier part to the question, you can still pick up there and continue to earn your points, continue to work out the problem, and acting like you just got the entire first part correct as well. So that's a nice advantage on the test. You don't have to necessarily build upon part by part to get all of the other parts correct. So in this method, what it asks us to do is to save the original text we have into this save text right here. If you look at your packet, I don't have the entire thing written up here, but this save text is simply a list that keeps track of all the text items that we are modifying. So every time we want to replace or modify a string of text, we want to save the original text. That way we have sort of a backup in case we want to undo that replace all, which we will see in just a minute in our second part. We have a way of retrieving that text. So once we erase it, it's not gone forever. We can always access that again. And then what we want to do is go through this text after we've saved the original copy. We want to actually modify it by looking for this key word, key substring part, which is this phrase called what. Now, this substring, again, what is just a reference to an actual line of text. So in the previous example, if I had used the phrase question as my what, that means question would be the word I'm looking to replace. So every time the word question appeared in that text, it would be replaced with this substitute word, which again in the last example we used the phrase problem as our substitute text. So this would be a really short way of implementing that previous method. I could simply call the replace one, tell it what I was looking to replace, that's why it's called what, and then what I want to put in its place, what I want to sub in, and that's why we're referring to that as sub. And then again, just like the last problem, we want to return our modified text. So we're going to work through this one together. Part 1 of this question, with this replace all method, it asks us to save the original text in save text. Again, this was a list of string objects. If you look at the method, or excuse me, at the instance variable save text in your code, you will see that save text was a list. So if I want to add more text to that list, easiest way to add text is to simply add it onto the end. And we have a method called the add method that simply says take the name of the list, which in this case is save text, and then we call the method, so dot add, since that's the name of the method, and we have to give it a parameter. What do we want to add to the list? We want to add the original text before we modify it, so we're simply going to say add our text. So it goes to the list, adds in the string that contains all of that text. Okay. So now if we modify the word text, we're actually not modifying what was stored there. That string is already stored in the list. Now anytime we change what text equals or do anything to text, we are referring to sort of a copy, so to speak. So when we say add text to the list, what it's doing is it's almost like adding a copy of that text. Or what it's doing is adding the original text to the list, and then whenever we modify it, remember strings are immutable, meaning we can't change what is stored in a certain string's location in memory. All we will do is we'll build a new string with pieces of the other one, but that's going to be stored in new memory locations each time, so we're never actually modifying this right here. So what we're going to do after we save the original text is we want to begin looking for this key phrase what in our original text. And anytime you want to know where something occurs, because remember, if we are wanting to use the replace one method from the previous example, I'm just going to scratch this out real quick here. If I want to use replace one, which will return a string, I have to give it 4 parameters. The text we originally have, the index for where that replacement needs to happen, the number of characters we're replacing, and then finally our substitute word, what we're putting in its place. So that's how that method works. In this question, it specifically told us to use this method. And if we rewrite text or code that could be addressed by this method, then we won't get full credit. You may get points taken away. So make sure that we actually make a call to this. So in order to know to call this replace one, I need my original text, which we already have. But instead of the word to look for, I need to know where that word is and then how long the word is. So if I want to know where this phrase appears in our word, what I can do is make an integer variable. I'm going to call mine index to represent where that phrase appears. And if you ever want to know where a text or a substring or a phrase appears in a line of text, you simply take the original text or the larger string you're looking inside and call the indexOf method. Again, this is on your AP Java subset handout where you can see all these string methods listed out. In the problem, I think it even specifically told you only use the indexOf and the length methods here. So the indexOf, and then we tell it what to look for. So we're saying, where is the index of this phrase what? Where does that appear in our text? And that'll return one of 2 options. It will either tell us the original character where that position, or the original position of the first character in the phrase what. So in the last example you saw where we had the word question, if that was our what, the word we are trying to replace, then that started at position 5. So if I say text.indexOf question from that original text we saw in 1A, then it's going to return the number 5 because that's where that phrase started. However, if the phrase doesn't appear, you probably already know this, all it will return is the integer -1 because that's an impossible index to have in a string of text. When the string start at 0, go to the last position is always this length of the string minus 1. So -1 would never be a possible index, so that's why it's used as sort of the signal that it does not appear in the actual string. So we're going to store that index for wherever it is as the word index. Now, if it does appear in the word, we want to change that word using the replace one method. We're going to replace that phrase with the word sub. And then we also want to check against the case of what if the phrase we're looking for appears more than once. So for instance, if I saw the phrase, this question is a harder question, and I wanted to replace the word question with problem in this case, so this would be my original text, this entire thing here. Maybe I want to replace what our keyword is. We want to replace the word question with the substitute word problem. Right? So, if I think about this, I actually don't want to only do this once. I want to replace it every time that word appears. So even if I had a phrase, a line of text that just said question, 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 I would want it to pick up every single one of those examples and replace it with the word problem. In the examples they gave you in the text, and always make sure you read the examples they give you. Those are usually a good hint as you're looking at it. It said, what if we have this phrase and our what word, the phrase we're replacing, is AA, and we want to replace that with the letter B. Well, here is an AA, we want to replace that with a B, and then here's an AA, we want to replace that with a B, so this is what our final result should be. So we need to make sure we put a condition in here so it will check that multiple times. The way we can do that, among other ways, one way would be to create a while loop and simply say, while the index is a valid index, in other words, it's at least 0 and somewhere within the size of the word, it's never going to return an index bigger than the size of the word, so that's sort of a safety net. But as long as it is greater or equal to 0, that's going to be a valid index. So that's when we want to replace something. If it's not, we don't want to change anything. We want to leave the text the way it is because apparently that phrase what doesn't appear in our text. So we don't want to modify it at all. But if the index is valid, what do we want to do? We want to replace wherever that appears, which is actually stored as index right now, we want to replace that with our keyword sub. So the way we're going to do this, we are going to take our text that we currently have, and we're just going to replace that text with a modified version of itself. So the way we do that is we're going to call the method, which in fact returns a modified string. We want to say take the current text, go to the position of wherever this starts. That is now stored as index since we use the indexOf method. The length of the phrase, now we're not told that here, but we can always figure out the length of a phrase or a string by calling the .length method on that string. So this is what we want to replace. We want to replace every character of that phrase, so that's going to be the length of that phrase what. And then we want to replace it with the keyword sub. So that's going to do the replacing for us. It will return that modified text and we're storing it back as text. Okay? So then all we want to do is check the modified text and see, do we have another example of what appearing in that phrase. So we're just going to take index and look for, in the new text, or the modified version, what is the index of the key phrase now. Now if the word only appeared once in the phrase, then we're going to get -1. And when we come back up here and check our condition, -1 won't be greater than or equal to 0, so it leaves the loop. But if it gives us another index, that means we've replaced 1, and now there's another index where this occurs. So for instance, in this example up here, the first index of question was 5, so it's going to replace this with the word problem. Okay. Now we'd have to go back and count our letters again. Since problem is a little bit shorter than the word question, our indexes are going to change just a little bit. This will still be 0, 1, 2, 3, space is 4. Problem will start at 5, R is 6, O is 7, B is 8, and so on until we figure out what the index for this question is. That's going to be stored here after we've done the first replacement. Since it will be a valid index, the loop will run a second time. It will replace this question with the word problem. And then it'll just check again for the word question anywhere. Since it doesn't appear anymore, it's going to give us -1, so then we will leave the loop. Okay? So there is one other thing we need to do here, and that is to return our modified text. So, whoops, see if I can back this up here. Just kind of zoomed in on me. Come on. Well, I want to squeeze this in down here. So that's somehow like twisted and modified. I'm not really sure what happened there. But what we would do is we would squeeze in the phrase return text, because remember we kept overriding our text with the new text each time. So we've replaced all the keywords. We now return our text and our method is done. Okay? So hopefully that made sense up until the point where everything kind of freaked out, and you now know how 1B part 1 works. So now go on to part 2 of this, which is the undo replace all. So how would we undo this method? And I think that one's going to be even simpler than maybe even the first two. So that's question 1B part 1.